All right, this is a video for the third test in Math 137. We're looking at the last three problems, the word problems in the calculator portion of the exam. So we're starting off with this problem where there's a cat stuck in a tree across the street from an apartment building. So let's draw what we know about that. So we have a ground level and we have a tree. We have a cat stuck in a tree. We have an apartment building across the street. And there's a residence that is 15 feet above the ground, and he's looking up at the cat, so he needs to be below the cat. So there's his window, there's his eyesight. And then from this person, we're going to be doing, so measuring from here, we're going to be saying that they're looking up at the cat, and there's a horizontal line of sight here. And that is a measurement of, it looks like 17 degrees. And that looks like 170. Let me back that up. So 17 degrees. Okay, and then we have a second person who is higher up than the cat at 85 feet from the ground. So this is now 85 feet. And they have a horizontal line of sight as well. It's not a very good horizontal line. And they're looking down at the cat. And that is 63 degrees for that angle of depression. So we have an angle of elevation down here of 17 degrees and an angle of depression at the 63 degrees. We can connect these two people together by drawing a long line between them, and we can figure out the length of that by doing 85 minus the 15, which would give me a 70 for this side of this triangle. Okay, so here's what we know so far. The portion right here where this connects, this dashed line to this red part of the building, that is going to be 90 degrees. So if we do 90 minus 17, that will tell me how much is inside the triangle here. So that would be 73, it looks like. And 90 minus 63 will give me the angle right here, because this is also 90 degrees. I've drawn mine a little bit funky, but we're going with it. So this is 27 degrees. Now we can use that to find this angle at the cat, so we need to add those together and then subtract from 180. So 180 minus 73 minus 27 is going to give me an 80-degree angle at the cat. Okay, so we know all three angles here, and we know a side. Because we know an angle and a side across from it, we can use the law of sines here to find, and because I want to know the height of the cat, I'm going to try to find the length of the bottom part of this triangle. So I'm going to do sine of 80 degrees over 70 equals, and then to find this side down here, I'm going to call this x. I need to use 27 since that's the angle across from that. So sine of 27 degrees over x. We're going to cross multiply, so we need to do 70 times sine of 27. And then divide that by the sine of 80. And I'm getting 32.27. Okay, so that's this length right here. And that is in feet. Now, what we want to do next is we want to form another triangle. And that triangle is, we need to know the distance from here to here, because we already know that this down here is 15. So we're looking at this little triangle down here. Okay? And what we know about it is that if you drop down a line to a horizontal line perpendicular, you have a 90-degree angle there. So we have this little triangle down here we're looking at. So we know, if we want to know this little piece right here, this is y, we know that if this is a 90-degree triangle, we should be able to use either sine, cosine, or tangent. So since this is opposite and hypotenuse, we're going to use sine. So we're going to use sine of 17 degrees equals opposite, which is y, over this side we just found, so 32.27. And that means we need to do sine of 17 times that. 32.27. And that gives me 9.43. So this right here is 9.43. This is 15 because that is the height, the same height as we had horizontally across. So 15 plus 9.43 is 24.43. We're supposed to round to the nearest whole foot, which comes out to 24 feet. Since it's not a 0.5 or above, we keep it 24. So there's the cat problem. Okay, let's look at number 15. It says a farming supply salesperson manages a territory that is triangulated by Indianapolis, Chicago, and St. Louis. So St. Louis is down here, Chicago is north of that, and Indianapolis is over here to the east. Doesn't matter if it's drawn perfectly to scale. So that's what we have, is a triangular region there. They told us that Chicago to Indianapolis is 180, and Indianapolis to St. Louis is 240, and Chicago to St. Louis is 297. So we know the three sides of the triangle. How much territory? That means area, because you're talking about the parts inside the triangle. So we're actually trying to figure out how much area or territory is this. Now to do area, we have Heron's formula. We have the law of sine. Not law of sines. We have the sine formula for area. So in this one, I was actually wrong. I would actually do this by Heron's if you don't mind doing Heron's formula, but you could also do this one by finding the largest angle using law of cosines and then doing the 1/2 side, and then the angle in between. So both should give, I'm going to do both just so you can see both. So if I use Heron's, then I need to find my perimeter of my triangle, which is 297 plus 180, 297 plus 180 plus 240, which comes out to 717. And you need half of that to use for the formula. So we cut that in half. That's 358.5. And then what Heron's formula says is that the area is equal to the square root of that number S, 358.5, times 358.5 minus each side. Minus 180, and then 358.5 minus 240. Okay, so if we want to figure each of those out, minus the 297 is 61.5. So I have square root of 358.5 times 61.5. And then we need to do 358.5 minus the 180, which is 178.5. And 358.5 minus the 240, which is 118.5. Okay, so we multiply all those together, so times 178.5 times 61.5 times 358.5. Then we take a square root of that. So that comes out to 21,595. We're rounded to the nearest square mile, so that means a whole number. So 21,595, since that's a 0.3, so it won't round up, and that would be miles squared. That would be the area of that region between those three cities in a triangle. If we want to use the area is, we'll call this little side L and this little side C. If we want to use 1/2 LC, then we have to have Indianapolis's angle. So sine of I, then we're going to need to find I. So if you want to use this version, you're going to have to use law of cosines to find that I angle for that. So that would be 297 squared equals 180 squared plus 240 squared minus 2 times 180 times 240 times cosine of I. And I worked this out earlier, and I'm just going to do it quickly. So I did 297 squared minus these two guys that you can subtract over, so 180 squared minus 240 squared, and I just got that as negative 1791 on this side. Then I multiplied these three numbers together in front of the cosine I, so that's 180 times 240 times a negative 2. That's negative 86,400 cosine of I. We would divide by the negative 1791 by the 86,400. So they're both negative, so it's going to come out positive. So I'm not even going to worry about the sign. And then we take an inverse cosine of this. And that comes out to 88.81 degrees. That's for I, sorry. So that's this angle right here. So if you find it using this way, you can now plug it into the formula. So area equals 1/2 180 times 240 times sine. It's very late. Remember the area formula, if you use this, is always sine of 88.81. Okay, so we do sine of that. I'm just going to keep it as it is, times the 240 times the 180, and then we cut it in half. And notice you get the 21,595 again. So 21,595. So either way, there were two ways you could have solved this. Either way gives me the correct answer. All right, our final example is about vectors and a force. So it says 2 ranchers are pulling a horse out of a batch of quicksand. That's a unique situation. The first rancher pulls with a force of 175 pounds, and the second rancher pulls with a force of 225 pounds. There's a 35-degree angle between the two ranchers' ropes, so in between the two vectors, and we're using to pull the horse from the quicksand. What is the combined force? That means if you call this rancher 1 and rancher 2, we want to know what would be the vector R1 plus R2, and we'd be looking for its magnitude since they said the combined force. Because the force of this one is 175 and the force or magnitude of this one is 225. Okay, so we want to go to the nearest whole pound of force. So the best way to draw this picture, and excuse my drawing because I'm drawing me a little horse. Ooh, he's stuck in the quicksand. He's almost drowning. Poor sad horse. The best way to draw this is to think of that horse having a center of kind of direction. So north, south, east, and west around the horse. And then draw the vectors as if the first one you draw is on the x-axis. We can draw vectors wherever we want as long as they have their magnitude and their direction. They didn't tell us what the direction was. We just know that there's a 35-degree angle between them. So I'm going to draw the first vector as if it's on the x-axis. That's going to make our life a lot easier. So that is 175 pounds. And then we go up 35-degree angle, and we draw the second vector, which has a longer magnitude, so I'm going to draw it a little bit longer. And this one's 225. So what we want to know is what is so this is 35 degrees in the middle. We want to know the combined force, which remember that's this displacement, where this actually kind of makes a parallelogram. So we're looking for the vector that adds together to make those two. Now, to be able to do that, you have to have the coordinates of both of these red vectors. Those coordinates are found always by doing the magnitude times the cosine of the angle and the sine of the angle for the other one. So this is cosine of an angle, this is 175, sine of an angle. If your first vector is on the x-axis, you've made your life easy because it's 0 degrees. So that means that cosine of 0 is just 1, so 175. And sine of 0 is 0, so this is the actual vector here. It's just 175, 0, which you could have known if you'd placed it on the x-axis. This one you need a little bit more work. This one is 225, and this is why I placed this here, because now this 35-degree angle is the measure from the x-axis. So this is cosine of 35 degrees and 225 sine of 35 degrees. So we're going to work that out and get a decimal approximation for both of those. So cosine of 35 degrees times 225 is 184.31. And Sine of 35 times 225 is 129.05. Okay, to add two vectors together, we add their components. So this guy right here is 175 plus 189.31. So 189.31 plus 175, that's 364.31. And then 129.05 plus 0 is just 129.05. Now those are the components of the vector. That's like its x and y. We wanted its magnitude since we wanted the combined force. So remember, to do magnitude, you take the square root of the two components added together like Pythagorean theorem. So 364.31 squared plus 129.05 squared, and it's under a big square root. So let's square this guy, plus 129.05 squared. Hit enter, and then we're going to take a square root of that. So it's 386 if we round to the nearest whole. So 386 pounds. And that is the end of this video. Not the end of the video. Sorry, fake shout. I found an error in what I just did. Sorry. When I added 184.31, I think I must have typed 189. So 184.31 plus the 175. This does change my answer a little bit. This was 359.31. So yeah, I was too high. And then I need to change that and redo the calculation. Sorry about that. So if we square that, plus 129.05 squared equals square root, it's 382. That's what the answer key had, but that's also what I got when I worked this earlier, and I had switched which vector was which, so I kind of noticed that that wasn't right, because before I put the 225 on the x-axis and the 175 up. It doesn't change the answer, but I just made a typo on when I added those two vectors together. So just ignore that. And the true value was 359.31. All right, now we're good.